when we're doing elimination, we have to find the value of r and t. What we're really finding is where the two lines intersect. And three things can happen that we're going to talk about today. The first thing would be that the two lines intersect at a point like that, and that would be one solution, right? And it would be the point. So if that's, let's say, 2, 2, then the answer would be 2, 2. And that would mean x is 2 and y is 2. The next way the two lines could be is that they could look like this when you graph them. Two parallel lines. So where are those two lines going to intersect? Never. So this would be no solution. And does anybody know what the third way would be that the two lines can look like? Very good. They would be the same line. So they'd be kind of on top of each other like that. And this solution would be infinitely many. And that's what you write as your solution. Because every point on each line is a solution because they intersect on every single point. So the word elimination means you have to eliminate one of the letters in order to find the other letter. And then you can plug it in to find the second letter that you just eliminated. And that's what we're going to do. So when I look at these equations, I need to look at each letter individually. And there's not always one clear way of doing it. I could eliminate the r's and I could eliminate the t's by doing different things. So we have to decide which way is the easiest, which one is the easiest thing to eliminate. And I think the t's are, because you have both of them, they have the same coefficient. They're both 1t, right? And what you have to do is you have to find a way to make the t's opposite of each other. So you've got to make one of the t's negative and one of the t's positive. So if I multiply this bottom guy by -1, look what happens. We have negative r plus t equals 5, because I didn't change the top one. And then we have 2r minus t equals -4. I gave -1 to everybody. Can you guys see what happens when I add these two equations together? What happens to the t's? They cross out because they're negative t and a positive t. So -1r and positive 2r is 1r. And 5 minus 4 is 1. So we already found the r. That was the path of least resistance. We could have eliminated the r's first and found the t. It just would have taken a little bit longer, but it works, okay? So what do we do to find the t? You plug in that 1 in for r. So we have a negative and then a 1, sorry, plus t equals 5. So when we add 1 to both sides, we have t equals 6. So that is the solution. And when there's letters other than x and y, you put them in alphabetical order in your coordinate pair. So it would be 1, 6 is where they would intersect on the graph.
Can I go see Miss Neal?
So when you have all the letters disappear because they equal 0, and they equal a false statement, like here, 0 equals 8, the answer is no solution. But if it gives you a true statement, and it could be 4 equals 4, depending on where the numbers are, it could be any true statement, the answer is infinitely many, since 0 equals 0. Those two are actually the same line when you graph them. Okay, so here we have a small problem, but you know, we can fix it. We can do it. We've got nothing that can be easily converted to each other. Let's look at the m's. Can I convert a 4 into a 3? I could, but it would take a fraction. We're not doing that, okay, because that would be a disaster. Can I convert a 2 into a 9? That would be another fraction. That would be hard to do, okay? So we're not going to do that. What we're going to do is we're going to multiply this guy up here. If I'm eliminating the m's, you can eliminate the p's also, but I'm eliminating the m. I'm going to multiply this guy by 3 and this guy by 4. And look what happens. This is 12m minus 6p equals 0. And this is negative 12m plus 36p equals 20. Everybody see that? So we take the first equation, multiply it by 3. The second equation, multiply it by 4, which will give us a 12m and a negative 12m. We do all the math and multiply the 4 and the 3 by everybody in the equation. And we come up with p equals 2/3. And then we plug in that 2/3 for p and find that m equals 1/3. This time we're going to eliminate the p's. So I'm going to multiply this guy by a 9, which will give me negative 18p there, and this guy by a 2. So we have 36m minus 18p equals 0, and negative 6m plus 18p equals 10. And this ends up being 30m equals, the p's bite the dust, 10. Divide by 30, and m equals 1/3. You see how it's still equal what it used to be? You just found it first. So now we have to plug in the 1/3, negative 3 times 1/3 plus 9p equals 5. 9p equals 5, and this here is a minus 1. So this is plus 1. 9p equals 6. Divide by 9, and p is 2/3. And it's the same answer we got before, but in reverse order.